Space is truly fascinating. The vast expanse of the universe is filled with unusual and frankly weird phenomena. So we've searched the far reaches of the cosmos and put together some of the most bizarre anomalies out there. Some anomalies are a little more puzzling than others, so brace yourself for the mystery box that is space. Nuclear pasta. When you think about some of the hardest substances in the world, things like diamond and steel may come to mind, but neither of those even comes close to nuclear pasta. This substance is created from neutrons and protons left over from the core of a neutron star. The intense gravitational pressure at the core of the dead star compresses these subatomic particles into a hard clump of pasta. This pasta is so dense, it would take more than 10 billion times the amount of force needed to shatter a diamond to even crack it. Neutron stars are so dense, compressing an entire sun's worth of mass into a tiny core barely 12 miles in diameter. For context, imagine the entire mass of Earth crammed into a space the size of New York City. At the surface of a neutron star, nuclear pasta takes the form of bubbles known as gnocchi. A second layer below the gnocchi is compacted in spaghetti-like shapes. A third layer looks more like flattened lasagna, with flattened strips stacked on each other. Each layer of nuclear pasta on a neutron star is about 100 meters thick, and each of these layers has more mass than 3,000 Earths combined. Nuclear pasta is so strong, it's practically indestructible, able to exist as part of a neutron star for billions and maybe even trillions of years. Black holes. Black holes may be a common topic in astronomy, but they are some of the strangest and most fascinating objects in space. These extremely dense regions of space break every known law of physics by swallowing up everything they encounter. Black holes exert such strong gravitational attraction that not even light can escape their grasp. The event horizon of a black hole isn't like the surface of any object in the universe. It's rather a boundary that no laws of physics can explain what lies beyond. Whatever crosses the event horizon reaches a point of no return and is either destroyed or funneled into some unknown region of space that scientists are unable to tell. Some have suggested sending probes into a black hole with the hopes that we might learn what lies beyond the event horizon in those last seconds before the probe is irretrievable. But even that wouldn't work, because the pull of a black hole is so powerful that not even a signal transmission from any probe would make it out. Observing black holes is equally difficult, as they do not emit or reflect light. The only way scientists can observe them is by observing the warped space around black holes. This is because black holes quite literally bend the fabric of space-time around them, and if they happen to be feeding on space matter or light, this creates a hue of light around them that can be observed. So except a black hole is near a star or regions of light, they are practically invisible. This means a small black hole could be zipping right past our solar system, and we wouldn't even know. But no need to panic though. Scientists believe the closest black hole to us is about 1,000 light years away. Small stellar black holes populate most galaxies like ours. Scientists estimate that there are about 100 million of these stellar black holes in the Milky Way galaxy, and we might never know where they all are. Supermassive black holes, on the other hand, are less common, reaching millions of times the size of the Sun, and are found at the center of most, if not all, galaxies. One great example is the supermassive black hole at the center of our galaxy, Sagittarius A. Sagittarius A is over 4 million times the mass of our Sun. And if you were unfortunate enough to be sucked in, something even weirder would happen. Because of the intense gravity of Sagittarius A, your feet would immediately get pulled in more than your head, stretching your entire body. This is known as spaghettification, and definitely won't be as fun as it sounds. Dark matter. Dark matter is yet another anomaly in the universe. Much like ordinary matter, dark matter has mass and occupies considerable space in the universe. But unlike ordinary matter, it does not reflect, absorb, or even radiate light. Dark matter is totally invisible to us, as it emits no light or energy that our telescopes can detect. So you might be thinking, how can astronomers know it exists if we can't see or even detect it? Well, scientists are able to prove the existence of dark matter by calculating the gravitational effects it has on ordinary matter in the universe. They observed that the gravitational pull of galaxies across the universe is greatly more than all the observable matter in the universe can account for. As such, there must be some invisible matter providing more mass and exerting more gravity on galaxies across the universe. Studies show that while ordinary matter accounts for about 5% of the universe, dark matter accounts for over 25%, making dark matter more abundant in the universe. The origins of dark matter are still a mystery to science, although there are theories that suggest they could be the product of black holes. This is because the event horizon of a black hole has incredible gravitational force, but doesn't not emit light or energy, similar to the properties of dark matter. But however mysterious dark matter may be, the technological implications for space travel are huge. Imagine harnessing dark matter as a fuel source. With its incredible abundance, it would serve as a near infinite energy source. Dark energy. If you thought dark matter strange, dark energy raises the bar on the anomaly scale. Scientists discovered that there is an unknown force exerting a negative pressure across the universe. This force is actively stretching the very fabric of space and time, pushing stars and galaxies further away from each other. Astronomers describe dark energy as an anti-gravitational force, or to put it plainly, the evil twin of gravity. While gravity is the force that holds objects in the universe together, dark energy pushes them apart, and is doing so at an increasing rate. The explosive gravitational waves that gave rise to our universe have their origins in the Big Bang, some 13.8 billion years ago. These forces are constant and have been since the universe was born. However, our studies of exploding stars revealed that something happened around 5 billion years ago. Some mysterious force caused the rate of the universe's expansion to speed up and has been increasing ever since. This force was named dark energy. Dark energy isn't just expanding the universe, but doing so at speeds that break one fundamental law of physics, moving faster than the speed of light. To prove this, astronomers studied the light from a galaxy named GNZ11, which is some 32 billion light years away. Dark energy is pushing GNZ11 away from us at speeds of 420,000 miles per second. This is nearly twice the speed of light, a speed constant that was thought to be unbreakable by any object in the universe. Dark energy is one of the few anomalies in the universe that isn't bound by the laws of conventional physics, and still leaves scientists puzzled to this day. Fast radio bursts. You might think radio signals only originate from Earth, but there are actually radio waves emitted from outer space that are 1,000,000 times more powerful than anything we have on Earth. Fast radio bursts, or FRBs, are such cosmic radio waves that are blasted out from deep space with more energy than the sun puts out in 3 days. These powerful radio waves are so fast they are emitted at 1,000ths of a second. FRBs blip in and out of existence so fast that it is incredibly difficult for astronomers to study them. Scientists believe FRBs originate from magnetized cores of dead stars, also known as magnastars. These dense cores spin at incredible speed with powerful magnetic fields, some spinning hundreds of times a second, shooting out radio waves in the process. These cosmic signals travel at the speed of light and can take millions of years to reach us. By the time most FRBs reach Earth, they are 1,000 times weaker than a telephone signal, adding to the difficult task of tracing their origins. One FRB is estimated to have taken 8 billion years to reach us, meaning it was already halfway here when our solar system was still forming. For an FRB to have traveled that long, scientists estimate it had more energy than our sun puts out in 30 years in the milliseconds blipped. Another strange anomaly about FRBs is that while most tend to occur once, one radio signal from deep space has been observed repeatedly, originating from a possible magnastar 1 billion light years away. FRB 202220912. A has occurred 35 times in over 2 months. Cosmic anomaly or aliens? Pulsars. Pulsars are another cosmic anomaly, taking the crown as the fastest spinning objects in the universe. They spin anywhere from 3 times a second to as much as 700 times a second. Pulsars are spinning neutron stars that blast out pulses of radiation at regular intervals. They have extremely powerful magnetic fields that funnel jets of high-beam particles of gamma rays along the 2 magnetic poles. These pulses typically range from milliseconds to a few seconds, but are powerful enough to obliterate anything in their path. Pulsars are incredibly rare in the universe, and it is estimated that a new pulsar is created somewhere in the Milky Way galaxy, at least once every 25 years. Scientists studied a pulsar measuring 10 miles across, designated PSR 4415, located some 1,600 light years away. The beam from this pulsar stretched about 40 trillion miles long. the longest ever observed from any pulsar, rogue planets. It would be normal to expect all planets to orbit a host star, because the formation of a star leads to the formation of planets. And while that may be the case for most star systems, some planets break away from the gravity of their host star, floating alone through space. These free-floating planets are known as rogue planets. So far, astronomers have identified over 5,000 rogue planets, all of which are Jupiter-sized planets. There are estimated to be millions of rogue planets roaming the galaxy, some of which may collide with existing star systems like ours, causing disruptions to the system. If a Jupiter-sized rogue planet entered our solar system, it could collide with any planet, most likely knocking it out of orbit. But astronomers believe that's highly unlikely. What other cosmic anomalies do you know and would like us to talk about? Let us know in the comments, and we'll see you in the next video.